Purpose of today's lesson is to learn how to solve a system of linear equations by substitution. Yesterday you learned how to solve a system by graphing. Today we're going to do one of the two algebraic methods. Remember, a system of linear equations just means two or more equations with the same variable. So we're going to follow the following steps. Step one is we're going to solve one of the equations for one of the variables, x or y. It could be a, b, c, or d, but let's just stick with x or y. When possible, solve for a variable that has a coefficient of 1 or -1. Step two is we're going to substitute, hence the term substitution, the expression from step one into the other equation and solve for the other variable. Step three, we're going to substitute the value from step two into either original equation and solve for the second variable. And then finally, we're going to write your solution as an ordered pair and insert into both equations to check. Now, if at this moment you're saying to yourself, I have no idea what he just went through, don't worry, because when we go through the examples, it will hopefully be much clearer. So let's take a look at the first example. I have two equations, y equals -4x minus 8 and y equals x plus 7. Well, hopefully you'll recognize that if y equals this and also equals that, then these two equations must be equal to each other, or statements must be equal to each other. So all I'm doing is taking x plus 7 and placing it in for y, or I'm taking -4x minus 8 and placing it in for y there. Now I have one single equation with one variable, and it's a very straightforward linear equation that we're going to solve. So I'm going to add 4x to both sides. Subtract 7. Divide by 5. And I get as my answer x is -3. However, you're not done. That's only half of the solution. I need to figure out what y is. I then substitute x into either of these two equations. Always choose the easier, which is the second one. And you figure out that y is 4. So what is your answer? 3, 4. And what the last step was saying, as a final check, if you put 4 in for y and 3 in for x into the other equation, you will, or -3, I'm sorry, so I'm looking, you will get a check. If you were graphing, this would be the point of intersection. It all intertwines. So my solution, and I'm sorry, that's -3, 4. Okay? Now let's do the second one. It's a little different, and I'm just going to extend this to give me a little bit of room. It's a little different in that both of them aren't y equals, but one of them is. So what I can do is I could take this statement, which is what y is, and substitute it in for y there. So now I get 4x minus 2 times -2x minus 3 equals 14. So if you notice what the objective is to get one single equation that has one variable only. Now I'm just going to solve this linear equation. I get x is 1. Now I want to figure out what y is. I'll take either of these two. The bottom one seems a little bit easier. And I get y is -5. So my solution, 1, -5. Okay. Let's go on to the next couple of examples. Now, if you'll notice here, neither of these two equations are set up as x equals or y equals, but they're both easy enough to do. So I'm going to change this, and just to show you, I'm going to subtract 2y from both sides to make it x equals negative 2y plus 2. Now I'm going to take that statement and replace it into the second equation for x. So I get 3 times negative 2y plus 2 plus y equals 16. Now, you might be saying to yourself, could he have taken the second one and made this y equals, which would have been y equals negative 3x plus 16, and substituted that into the first one? And the answer to that is yes. It's just a matter of what you choose. Negative 6y plus 6 plus y is 16. Negative 5y plus 6 equals 16. Negative 5y equals 10. Y equals negative 2. Okay? Now I want to figure out what x is. I substitute negative 2 in for y into either equation. And I find x is 6. 6 comma negative 2 is my answer. Okay? Scrolling down. One of them is already set up nicely for me, so I'm going to take this statement and replace it for y. What you need to be careful about is when you replace, you put it inside parentheses, because you're going to distribute this minus sign. You get 3x minus 3x plus 7 equals 7. And you're left with 7 equals 7. Now, hopefully at this point, you're remembering from earlier in the year when we got an equation and the variables were eliminated, and I'm left with a true statement. What our solution is all real numbers or infinitely many solutions. What kind of lines are these? Well, if we graph these, as you should remember from yesterday, they're coinciding, or they're the same line. Okay? And our last example. Again, I'm not trued up to x equals or y equals, so I'm going to make this x equals 16 minus y. I'm going to put this in for x. So I get 2y equals negative 2 times 16 minus y plus 2. 2y equals negative 32 plus 2y plus 2. 2y equals negative 30 plus 2y. I subtract 2y. 0 does not equal negative 30. So, what's the deal here? No solution. What would happen if you graph these? They would be parallel lines. And if you solve this so that x and y were on the same side, what you'll see is the x and the y were multiplied by 2, but the number was multiplied by 8. That means it has the same slope, but a different y-intercept. So, to summarize, today's lesson was using the algebraic method of substitution to solve a system of linear equations where you want to get one of the two equations into x equals or y equals form, substitute into the other, and then solve.